Welcome back, and let's get right into it. Okay, so today we're going to talk about lists. So far we've worked with a few data types: ints, floats, maybe strings, booleans. And these are all single values, right? But you know, what if what if we're dealing with a collection of data? What if we're dealing with a collection of students and we want to hold all of the students' grades, right? It's got to be in some sort of um, collection, right? So we like to talk about lists in Python. So we're going to review the basics of lists, an indispensable data type in any programming language. So here are the basics. So here are examples of lists. So here is a list of numbers. And so this is how we actually declare a list. So we can write X. So we can write the variable name. Where does this list exist? Like what variable will hold the list? And then we use square brackets, and we separate each value by a comma. So this is a list of integers, one, two, three. Here's a list of strings. We can do a list of strings. Lists can be heterogeneous, meaning that they contain different things. So they don't necessarily have to be all numbers or all strings or all one type. So here's a list containing integers, strings, and another list. So you can have a list inside a list. So we have one, two, hello world. We have another list denoted by the square brackets, and inside that list it also has its own values. Length of lists and indexing. So we can determine the length of an array. Um, so an array or a list. Um, we in computer science we call something of this structure. It can be called an array. So that's another name, and it's more of a common name. So we can determine the length of an array and access the elements of the array or list through the indices or the index. So the built-in function len works for lists. So len gives us the length of the list. So we have our list X, and we have the items one, two, three, and we clearly is one item, two item, three items. So the length of the list is three. So when we use the built-in function len and we pass in the list, it will give us the length of the list. And the operator, the square brackets operator, is an operator accesses individual elements of a list. So if I want to access the element of in list X at the index 1, this is how we do it. We say X square brackets 1, and this will print 2, because the index for lists starts at, the counting for the index always starts at 0. So the first position is always 0, then 1, then 2, then so on and so forth. Okay. So lists are mutable, meaning they can be changed. Strings cannot be changed. Strings are immutable. For example, so this is very important. We can basically assign a value to a specified location in the list, but not in a string. So for example, we have a list called my list, and we have the items in there. We print the list. We print the second index 0, 1, 2. So that's going to be 15. And then we change. So we say my list at index 2. We want to assign a value 0. And then we print the list again, and you can see here 0 is in the position where 15 was. And now if we have my string hello world, and if we print the value of the second index, so H is 0, E is 1, L is 2. And here you see the L there in the screenshot there. So it prints. But then if we want to change that value to P, we can't do that because a string does not support that. So indexing. So write a program that prints the abbreviation for the month of a year, given its number. So we have a function called main, and inside main we have a list called months, and we have January, February, March, April, May, June, etc. So now, so this is all, look, this is all inside the scope of the main function. And then we say n, we want to take the input, give me a number between 1 and 12. Now, print the month, and then we print out this statement. The month is, and then we want to fill in, we want to actually fill in, we want to take one of the values from in here and replace this with it, okay? So what should the index be here? Think about it. Pause and think about it. Really think about it, okay? And then come back. Okay, so I hope you've paused and you've thought about it. The index here should be n, because that's what we're asking for. That's what we're doing when we're asking. So we're saying enter a month number. So we're taking that number, and then what we're doing is when we're saying months and we put n here, whatever the user put in, say the user put in 5, we're gonna go 0, 1, 2, 3, 4, 5. And then so then we're gonna print out the month is June. That's how it works. See, even I made a mistake. The month should it be n minus 1? Or should it be n plus 1? N minus 1. Yes, because this starts at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so we can represent it as, n minus 1, because we're going to be giving a number between 1 and 12. So when I want the first month, n is going to be 1, because I'm going to input 1, and then we're going to say 1 minus 1, which will be 0, and then we go here, and the 0th item is January. So that works. Okay, so adding and multiplying lists. The plus and multiplication operator works on lists, just excuse me, just like strings. And so we have the list A, we have the list B. So A is 1, 2, 3, B is 4, 5. And then we print out A plus B. So when we add the two lists, it combines them all into one list. And if we print B times 3, so B times 3 repeats this list 3 times. and it puts it in one list. So you can see 4, 5, 4, 5, 4, 5. That's 3 times. Slicing lists. So a useful thing we can do is slice lists. So we can use list slicing to get a part of a list. For example, we have the list 1, 2, 3, 4. Now we want to print out, so this is the syntax for slicing. So when we print out x and 0, 2, it's going to be everything in x from and including 0, index 0, all the way up to 2, but not including 2. So that'll be 0 to 1. So 0, 1. Those are the only ones we're going to include. And that's what we get here, 1, 2. And if we do 1 to 4, we want everything from index 1, including 1, up to 4, but not including 4. Index 4. Is there even an index 4? There is not, because we have 0, 1, 2, 0, 1, 2, 3. So it's going to give us everything from 1 to 3. So we get 2, 3, 4, because this is 0, this is 1, this is 2, this is 3. And can we slice a string? What will this output? Maybe try it out and see for yourself. So using the for loop with lists. So we can, just like with strings, we can use for loops to cycle through a list. So you can imagine what a useful application of this would be. Is say if we have a list of students and we want to find out if this student is in. So we say we have a list of students that take computer science. So we want to see if a certain student is in the class. So we have to find a way. We have to look through every single um, student in the list, right? So we need to use a for loop to go through a list, right? And so this is how we can do that. So we have our list 1, 2, 3, 4, and this is how we do a for loop. It's very simple. We use the keyword for. We want to have a variable that's going to store each element of the list. So we say for x in my list, print x. So what it's going to do is that this for loop is going to keep going until it reaches the end of the list. So when we start out, we're going to say x is going to be zero, is going to be index 0. It's going to be an index 0. So it's going to be 1. We're going to print 1. Then we're going to print 2. Then we're going to print 3. Then we're going to print 4. Then we're going to exit the loop. And so we can do this a different way. We can say for I in range 4. So in range 4 is going to be, this loop is going to go from 0, 1, 2, 3, and that's it. At 4, it's going to exit this loop. So what we're going to do is we're going to print out, so and then so I is going to just be 0, 1, 2, 3. So now we're going to print out the list at index 0, 1, 2, 3, which is going to do the exact same thing as this. But this one is cleaner and easier to read. This one is harder to understand. So using the for loops with lists. Okay. So yes. So this is using the index, and this is just by item. So max and min functions. These functions take a list as an argument and returns the max or min values in the list. So we have a list of numbers, and we have a list of letters. We have a list of numbers and letters. And we want to call the built-in function max, min, and max on these different lists. So, let's see. So here's the output. So when we do max of the numbers list, we get 99.99 because that's the biggest number. When we do minimum of the letters list, we get x because XYZ, because x is the smallest. Is this? It doesn't make sense to say smallest, but hold on. Sorry for that auto interruption. I'm back. So x is before y and z. Okay, and now we get an error, right? It says unorderable types int and string, and so we can't get the order. We can't. What does it mean to have the max of this list? Like, is a greater than 1 or etc. Right? It's not obvious. So here it says, however, lists containing both strings and numeric variables can now be ordered. So min and max will produce errors. In other words, the list needs to be homogeneous for these two functions to work. Homogeneous meaning the same. Okay, so the sum function. Python has a built-in function sum that takes a list as an argument and returns the sum of all the elements in the list. Elements need to be numbers, but numbers do not all need to be of the same type, i.e., all int nor all float. For example, the following code outputs 6.0. So the sum of 1 plus 2 plus 3 is 6.0. Delete function. We can use the del built-in function to delete an element from a certain position rather than by its value. The delete function can remove either a single element or all elements defined by a slice. This function takes a list as an argument and returns none. So what this means is that it takes it doesn't return us any new list or anything. It just does an operation on a list. That's what that means. So example, we have a list L, 1, 2, 3, 4, 5, 6, and we say we want to delete L 0. And that's going to make, so we want to delete the item, the element at index 0 in L, which is 1. So that's the new value of the list. Now we want to delete the slice from 0 all the way up to 3, but not including 3. So from 0 to 2. So from 0, 0, 1, 2. We want to delete all those. And that's what we get, 5, 6. And here's an example here. We have a list 0, 1, 2, 3, x equals 10. Delete L at index 10. Well, that's an error because 10, we don't have no items at index 10. This list only goes up to index 3. The delete function permanently changes the list, just like all of the list methods on the previous slide. It does not return anything. Adding and deleting elements of a list. To add an element to the end of a list, we use the dot append value. So before the dot, you want to have the name of your list, and then dot append, and then you put the value in the brackets there. To insert an element into the list, use dot insert. So we use the insert function, and it takes an index and a value. So we want the index represents where we want the element to go, and the value is the value. Now we can reverse a list, so we can use reverse. To remove the first occurrence of a value, regardless of how many times it appears, we can use remove. Okay. So why are these methods and not functions? So these are considered methods. So we have a list 1, 2, 3, and then we want to append 4. So that's what happens after we do append. Now, if we want to do insert insert index 2 minus 5. So it doesn't overwrite what's at index 2. It just adds something at index 2, and then it shifts all the elements around. If we want to remove the first occurrence of 1, that's what we're doing here. That's what we're going to do. And so 1 doesn't exist here. And if we want to reverse, we just call reverse on L, and that's it. So notice that each of these methods act on a list, in this case L. However, what do each of these methods return? Think about that. How does this code compare to the code for using max, min, sum, and delete functions? So the difference between delete and remove value is a method that searches through the list looking for a particular value and removes the first instance of it. Delete is a function where you can specify the exact location of the element that you want to remove. And so here we have a list of strings. Nintendo is not awesome. Is not awesome. Not. Remove not. And it's gonna remove. So this is gonna remove the first not in the string in the list. And so that's what we get. We get Nintendo is awesome. Not. But if we delete, now what is this? What is this index? So we say, what's the length of L? The length of L is at this point is 1, 2, 3, 4. So 4 minus 1 is 3. So 1, 2, 3. We want to remove awesome. Index. So 0, 1, 2, 3, which is going to remove the not. And that's what we do there. Now we have a sort method. The sort method sorts a list in place. It changes the original list and returns none. So when it says in place, it doesn't create a new sorted list. It actually moves these items around inside the same list and doesn't return anything. So here we have the list. We call a.sort, and then we print out A, and here it is sorted. So the built-in function sorted returns a new sorted list without modifying the source list. So this is different. This doesn't sort in place, but it sorts and it creates an actual new list in memory. So we have the list here A. Then we have a variable called new A that takes the sorted version of A. And here we're printing up both of them, and that's what we get. So the difference between them, the behavior of the dot sort method and the sorted function is exactly the same, except that sorted returns a new list instead of modifying the given list. So here's an example. So we have A equals hello world hello, and new A equals A dot sort. This makes no sense. New A will be equal to none. Yes, this will be equal to none because A dot sort only returns none. It doesn't return the list. This makes more sense here. We have A dot sort. Then we say new A equals A. So new A equals the sorted version of A, and then we print out. You want to do this instead. Searching lists, the in operator is an element in a list. We can use in, we can use the keyword in, or we can use not in to determine this. So here's an example. We have a list of items, and these are strings. So we say, if the string computer is in the list items, print 1. If the string atlas is in the list items, print 2. Else, print 3. If the string marker is not in the list items, print 4. So what is the output? Well, computer is in, so we print out 1. We don't print out atlas because that is not in the list. Else, print 3. So print 3. And then marker is not in the list, so we print 4. And that's what we get. So searching lists, the index method. So this method is used to search lists. We pass it an argument that matches a value in the list and returns the index where that value is found. So this method takes a value and it will return the index where that value is found. If no value is found, an exception is thrown. So we have a list of strings and it's called values. And then we have n is equal to, so n is going to hold the index of this string dos right here, because we're using the method index and giving the value dos. So we want it, so it's going to return us the index of that. So that's going to be 0, 1. That's going to be 1. Print n. So print n and then the value and values of n. So n is going to be 1 and then print 1, print the value 1. So yeah, so we get that. And then we want the index of tres, and we do the same thing. So tres is at 0, 1, 2, so index 2. And then here we want to try something. We want to try n equals index of the string question mark. There is no index there, so it won't be found. So try this. If this fails, print this. And that's what we print, not found. So list functions and methods warning. Be careful. If you do not take the time to think about whether the function or method that you are using with a list modifies the list or creates a new list, then you are going to have undesired results. So you have to understand what that method returns. Does it return a list? Does it return a value? Does it return none, which is nothing? Which, right? So that is modification and create. Before using list methods and functions, you should read the documentation carefully and then test them before using them. So list functions and methods in summary. List methods are all void. What does that mean? They modify the list and return none. If you accidentally write t equals t dot sort, you will be disappointed with the result because you'll get t would just equal none. List functions typically do return a value, max, min, len, sorted, with the exception of del, which returns none. Awesome, eh? So we have now learned over a dozen ways to work with lists. So we have the built-in functions, we have operators with lists, which is like the plus. We can add two lists together. We can use a multiplication operator to repeat a list. We can use the in keyword to cycle through. We can use this square bracket um, syntax to access or assign values to lists. We can slice lists. We can use the built-in functions. We can delete. We can sum a list. We can use the max. We can get the min. We can sort it, and much more. Enumerate. We can use zip. We can use any. We can use all. And so these are some things that you should maybe research. And here are the methods that belong to the list class or module. And so we have append, which adds a value to the end, remove, reverse, etc. Okay, so that's it on lists, and I believe we're almost done covering all the material, uh, if not all the material in Unit 1. So be on the lookout for quizzes, assignments, and then we'll nail down a date for the first test. And so I believe we'll have 2 or 3 more units, um, and potentially a group project. Okay. All right. If you have any questions, have them ready for me on Friday.